Okay, welcome to the second example in review of statics. The question reads, express the moment of the couple acting on the pipe assembly in Cartesian vector form. Solve the problem using A, Cartesian vector formulation, and B, summation of the moment of each force around point O. Take the magnitude of the force vector F to be 25 kilonewtons, and we're given this diagram right here. So to start off any question, we're going to write down our givens. And this is very similar to the last question, but instead this time we're given the force and we want to find the moment. So the magnitude of this force vector is equal to 25 kilonewtons, as the question says. What's the actual force vector equal to? As we said, I don't see any x, I don't see any y. It's purely, or this one is purely in the z, and we're going to go with the positive one. So the force vector F is equal to 0, 0, F 25, because we're given and immediately right then and there I'm gonna want to find the moment, so I want to put down this formula. The moment vector is equal to the position vector cross this force vector that I found. A quick rundown of what this question wants us to do for part A and for part B. So part A wants you to do the exact same thing you did last time. Okay, your R is going to be from RA to B, and then if you go from A to B, you're going to use this positive force F. You're going to cross them together. You're going to get the moment. That's your answer to part A. Part B, it wants to waste your time a little bit. It says, actually, I want you to take from O to B. I want you to take this vector, OAB, or OB, and take this positive force. And then, or let me write this down. And then I want you to go from O to A. And I want you to take this negative force, find the moment for this with respect to O, find the moment with this with respect to O, and then I want you to add them together to find one collective moment with respect to O. So it just wants you to do a bunch of stuff for the exact same answer you're going to get if you went the couple moment way, because this is different if you notice. As we said, this is kind of like a bending moment idea. You don't have two forces, you just have one force, F, for example, and then you have, in the ROB case, ROB. So like that, and then you have like that. So it's going to want to bend it like that. Perfect stuff. Assumptions, or not assumptions, unknowns. Assumptions is for thermodynamics, not this fun stuff. So assumptions is, or unknowns, we want to find our moment vector. We want to find our moment vector using the couple moment idea, couple moment, and then we also want to find our moment with respect to point O. Perfect. We're going to start off with finding all those position vectors. Again, we said we wanted 3 ones. For part A, we wanted from A to B, so we want RAB. For part B, we want 2 vectors. We want from RO to B, and then from RO to A. Okay, so we're going to say find our vectors. We said we needed 3, so RAB, ROA, ROB. You're going to get that RAB is equal to 0.35, 0.2, and 0. ROA is going to be 0.65, 0.4, and 0. ROB is going to be 0.3, 0.2, and then 0. And they're all in the xy plane, so that's why all of these are 0. Perfect. Now we're going to go the couple moment route, basically doing part A, but I'm not going to say that. I'm going to say find couple moment vector. And how do we do that? Again, just simply using the formula, the moment vector caused by the couple moment is equal to RAB cross the force F, and we're going to use the positive one as we said before because we're going from A to B. Once you do this calculation, once you do this cross product, you're going to get that this is equal to a vector, obviously, and it's going to be 5 in the x direction, negative 8.75 in the y direction, and 0 in the k direction, and then this is in newton meters. Perfect. So that's our answer for part A. Part B, it wants us to do, as we said, all this extra stuff. So it says find the moment with respect to point O. And as we said, that formula is simply m with respect to point O is equal to the position vector from O to point A cross the negative force, and I'll explain that in just a second by going back to the diagram, plus r from the position vector from O to point B cross the positive force. And if we say that on the diagram right here, from O to B, we're going to use the negative force. From O to A, we're going to use the positive force. And then from O to A, we're going to use the negative force. Once you do this calculation, this is, again, just simply a cross product. You're going to get that this is the exact same thing, but you're going to get something weird. You're going to get negative 5, 8.75, 0. Well, that's weird. Why is it different from our answer? Well, aren't they supposed to be the same? Well, technically it is the same. If you had, for example, if this also was negative, then you have a problem. But if you just multiply this by -1, you get your same answer, right? So it's not that big of an issue. And yeah, perfect. That is your answer. Just for formality, maybe don't, depending on your instructor, put it in the actual like IJK notation with the proper units. So 8.75 J, and this is all in Newton meters, and this is your final answer along with the